Hey everybody, this is 1.2 factoring quadratics. This is just a quick review from last year. We're going to skip past this first part. We kind of talked about that last time, but suffice to say, when we distribute, we end up multiplying. When we factor, we're going to end up dividing. So we're just doing the opposite of what we've done with distributing. We're going to divide out some factors, things that can go into the terms, okay? So here is just kind of like some steps, if that's helpful, but we're just going to go straight and do some of these problems. So we're going to start with talking about the greatest common factor. So again, the GCF is the greatest number or variable that you can find or divide both terms by. So if we look at this first example, first off we want to make sure that our problems are in standard form. Standard form means we have the higher exponent first down to the smallest with the constant last. So this one's not in standard form. We would want to move this 8x to the other side. We're just rearranging its position. We're not like adding or subtracting both sides or anything, okay? Now this is in standard form. Now we want to look for the greatest common factor. So there's three things we need to check: sign, coefficients, and variables. So if the first term is negative, then that's part of the greatest common factor. So here we have a leading negative. We're going to want to take one of those out, okay? Also, we'll look at the coefficients. This would be like a 1 and an 8. So the greatest common factor for 1 and 8 would just be 1. And sometimes you don't have to write that down. Next, we'll look for variables. Here we have an x in both terms, so we can factor out an x. If your problem, your expression, is in standard form, your last term will tell us how many x's you could factor out, okay? So once you've done that, then we just need to figure out what's left after we factor out the greatest common factor. So we need to divide all the terms by that greatest common factor. So here we have a -1 divided by -1. That would give us 1, okay? And then we could divide the x squared by x. Again, when we divide variables, then we can subtract their exponents. So this would just be x. And then we'll do the next term. 8 divide -1 will give us -8. And then when we divide the x's, those would divide to 1, or you could just say they cancel out, okay? So that is our factored form of this expression. All right, let's look at this one. Is this one in standard form? It's not in standard form either. So we would want to maybe move this 15x to the 5th over on this side. Now it's in standard form. We'll check those three things. Greatest or leading negative. There's not a leading negative, so we don't write that down. For the numbers, the coefficients, looks like it's a 5. And again, if it's in standard form, your last term tells us how many x's we could factor out. Okay. If you end up having a constant, then we can't take out any, factor out any variables. Okay, so now we will divide all terms by that greatest common factor. So 15 over 5 is 3, and then exponents 5 minus 3 would give us x to the 2, and then we'll just continue that. So we'll have -4x, and then watch out for this, if we have -5 divide 5, so that would be -1, okay? And then that would be our expression. There's a couple extras over here. Really the only thing you want to make sure, there could be cases where the greatest common factor is just a variable, or you could have like 1x squared. For this last example, we do have a leading negative. The greatest common factor for the numbers would be 4, but there's not a greatest common factor for the variables. So like this last term, it's just a constant. So we can't factor out, if we divided by like x, that would not work, right? It would not become it wouldn't be a polynomial anymore, right? Okay. So there shouldn't be any fractions or things in your answers. All right, so you can finish those up if you'd like. They are in the filled-in notes, so you could do that if you'd like. All right, factoring by grouping. So if you have 4 terms, so if you look at these 2 examples, they both have 4 terms. Then we can factor by grouping. Some of your teachers maybe did it using a box, some using something else where you like cut it in half and factor that way. Give you the same answer no matter what. So I'm going to do box just because that's what I did for Sec 2 last year. Okay. Again, we have 4 terms. We have 4 boxes. This is just a way to organize your factoring. So our first term is our first box. Our second term is our second box. Our third term is our third box. Just like you're reading a book, left to right, top to bottom. Okay? And then we just check for greatest common factors for each row and column. So here our first row, greatest common factor for 4 and 20 would be 4. And then there's an x in both terms, which means we can factor out an x. Our next term would be a negative 3y, because there's a y in both terms. We take a negative because the first term is negative. All right, our next is our columns. So greatest common factor for the columns here would just be an x, or you could do 1x. And then the last column would be 5. So you should be able to kind of multiply back and make sure that they match. So here we have 4 times 1 gives us 4. We could do 4 times 5 should give us 20, so that's good. We could do negative 3 times 1, that gives us negative 3. And then I'm running out of colors. Then we have negative 3 times 5 is negative 15. And you could do the same with the variables too, but usually people do pretty good with the variables. Sometimes people do like a common factor, like sometimes people would go like 2x instead of 4x. That would be a common factor, but not the greatest. Okay. Anyways, so now what's outside is our factors. We have x plus 5 and 4x minus 3y. Okay. All right, let's look at B. This is very similar. I'm going to go this one a little quicker. You could pause and give this a try if you'd like. But yes, you will run into this on the homework and on a test. So don't be surprised if you see 4 terms. It's basically, in last year we had like quadratic trinomials, and then we end up getting 4 terms. So we're kind of like that point already. All right, so greatest common factor would be 3x squared. Okay, so again, the last box or last term tells us how many x's we could factor out. 14 and 30. I think it's just 2. Wait, I think I messed something up. Oh, it's not 16. Just kidding. It's 15. I don't know how that happened. Sorry, I was probably talking while I was doing it. Okay, so that makes more sense. So this is 15. The first column looks like it would be 3. Oh. So this is something we need to talk about. And then we would have, what? This would be negative 6. Okay, so when we look at this and we multiply back to check, here we're like, it's too much, right? So 3 times 3 would be 9, but it needs to be 3. So what happened here is there is a greatest common factor that wasn't taken care of. Okay? I guess I probably could have saved this, but we'll just redo it. Okay? So we can divide everything by a 3. I'm just going to write it up here. This will actually make your numbers more easier to work with. Okay, so then when we're all done, we're going to have that 3 and those 2 parentheses. Okay, those factors. Okay, so now let's give it a try. Greatest common factor, x squared, 5x, and negative 2. Now if you were to multiply in, it works great. So we'll have x minus 2 and x squared minus or plus 5. Okay? All right. So now let's do factoring. Hopefully this isn't too bad. We did this before last year, spent a lot of time on this. So there's different types of things that can happen. We could have a equals 1. We could have a greatest common factor. There could be when a is not 1. So let's just go for it. Okay, so greatest common factor. There's not 1 here, so we're good. We should always check for that. And then we want to do the puzzle. So we want to figure out what multiplies and adds. Again, what multiplies is when you multiply the first and last terms. So 6b squared. And then has to add to negative 7b. And then you'd say, well, maybe negative 1 and negative 6. That could work. Okay. And then last year I shared that if that's the case, if a is 1, the leading coefficient is 1, then we can go and write our factors straight away. So here we have b minus 1 and b minus 6. No, I guess it's not an equation. Okay, so that's it. If you prefer to do the whole process of solving by grouping using like a box, you're welcome to do that. You get the same answer. So here we'll do this one a little quicker. What multiplies to negative 12 and adds to negative 1? Well, that would have to be like negative 4 and a positive 3. Okay, so that would give us negative 1. And if we multiplied, that would give us the negative 12. So here we would have x minus 4 and x plus 3. Okay? I promise I'll give you an example where you have to use the box. Greatest common factor. So if there's a greatest common factor, we want to factor that out. So we'll divide everything by 2. It'll also make it easier when you try and find the 2 things that multiply and add. So what can multiply to 20 and add to give us 9? So that would be like, nope, not 6. Just kidding, 5 and 4. Okay, so then our answers, because a is now 1, we factored out the 2, now a is 1. Our factors would be x plus 5 and x plus 4. Okay, so don't forget that you took out that greatest common factor 2. Should be part of your answer. Okay, let's do one more really quick. So here we have an x in every term, and we have a leading negative. So that means our greatest common factor would be negative x, and we'd get x squared minus 4x plus 12. Nope, not plus 12, minus 12. I probably should do this because that will help. Okay, now we need to figure out what multiplies to negative 12 and adds to negative 4. So perhaps -6 and 2, that would work. So again, since a is 1, we can just write our factors. So x minus 6 and x plus 2. All right, now we have it when a is not 1. We'll probably just do one of these. I have the other in the filled in notes if you want to have a look, okay? Trying to decide which one I really want to do. Yeah, let's do this one, okay? So we need to figure out what multiplies to negative 8x squared and adds to 2x. So think about that for a sec. Maybe 2 and 4. We could do 2x, negative 2x, and positive 4x. That would work, okay? So now we cannot, our answer is not x minus 2 and x plus 4. That is incorrect, okay? If you were to distribute that back, x times x would give us x squared, not 8x squared. So we have to use the box. The first term is the first box, so this. Your last term is your last box. And then our puzzle that we found, 2x and 4x, are the other two boxes. Greatest common factor, 2x, 1, 4x, and negative 1. Again, you can always multiply those and check. 2 times 4 is 8, 2 times negative 1 is negative 2, and so forth to check. But that would be our answer. So 4x minus 1 and 2x plus 1. All right, and then let's finish it up over here. This is the difference of squares. You are welcome to do it just how we did it before. Even for this one, a is 1, so you could just find the two things. Why don't we do it both, okay? First off, if it's the difference of squares, meaning this is squared and this is squared, right? 25 is 5 squared. Then your answers, kind of look over here. So if you have something that looks like this, then the a and the b are just the terms or variables that go in the factors, okay? So for this one, it would just be x minus 5 and x plus 5, okay? If you were to factor, then you'd need to figure out what multiplies to negative 25x squared, and what adds is always the middle term, which is missing, so that would be like a 0x. And you'd come up with 5 and negative 5, and you could just write our factors from there. So it's not too much difference, but sometimes you have the difference of squares that a isn't 1. And then this definitely helps to use the difference of squares. Like, for example, if you had something like 16x squared minus 25. Like, factoring that, find what multiplies to what you get when you multiply those. That's pretty big. That's like 400, okay? Where here you could just use the difference of squares. So this is 4 squared, x squared, or we could even write it like this. 4x squared minus 5 squared. So again, the difference of squared terms, we'd get 4x minus 5 and 4x plus 5. So that's really when you save a lot of time, or at least more time probably, if you do the difference of squares. Okay, so here's one more. You'll probably run into something like this on your homework too. This one has a greatest common factor. So we want to take care of that first. We can factor out a 2x, and we should end up getting x squared minus 9. And now that's a difference of squares. Okay, this is x squared minus 3 squared. So our factors would be x minus 3 and x plus 3. Okay, Again, you could factor that using doing the puzzle and all that if you wanted to. Okay, so I think that's it for today. So if you have any questions, please stop by. I'd love to help. See ya.